Hey everyone, welcome to The Explainer. So today we're diving straight into why GCSE physics often feels so incredibly tricky. And no, it's actually not just to torture you. We're going to explore how busting a few everyday myths can literally instantly upgrade your exam grades. If you've ever stared at a physics paper and felt like the subject was just deliberately trying to confuse you, well, you're in exactly the right place. Okay, let's kick things off with a huge question. Why do so many of us drop marks in physics, even when we study really hard? Have you ever felt like the exam is just full of trick questions? Well, here's the secret. It's actually not the exams that are tricking you. The real culprits? They're our own daily observations. You see, the way we talk about the world in our everyday lives completely sets us up to fail in that physics exam hall. Check out this quote from the Institute of Physics. They say, "Misconceptions are not mere lack of knowledge. They are alternative frameworks developed through daily experience." This is huge. It means you don't actually lack the knowledge. Instead, your brain is just relying on everyday glitches in how you observe the world. You've built this alternative framework that works great for, making a cup of tea, but completely betrays you in a physics exam. But don't worry, today, we're going to fix those glitches. All right, let's jump straight into myth number 1, the electricity box, where we tackle circuit misconceptions. Okay, read this statement to yourself. Batteries contain electricity and light bulbs consume the current. I mean, it sounds perfectly logical, right? When your phone dies, you plug it in to sort of fill it up with electricity. But wait, I need you to completely erase that sentence from your memory right now, because in the realm of physics, it is a massive conceptual trap. Let's compare that everyday belief with the actual physics reality. We naturally think batteries store electricity and current gets used up. But the reality? Cells store energy, and current is strictly conserved. To really get why, we have to zoom way in and remember exactly what atoms are made of. Every single wire in a circuit is just a massive collection of metal atoms. At the dead center of each atom is a nucleus made of protons and neutrons, right? But orbiting around the outside are those negatively charged electrons. In metals, some of these outer electrons are just totally free to move. They are literally already sitting right there inside the wires. The battery doesn't make them or supply them, it just provides the chemical energy to push those existing electrons along. So if the electrons are already there, what actually is current? Well, current is simply the rate of flow of charge. Imagine taking a stopwatch and picking just a single point on a wire. If you could somehow count the exact number of those electrons, those tiny negatively charged parts of the atom we just talked about, flowing past that specific point every single second, that rate is your current. And because those electrons aren't magically destroyed when they pass through a bulb, the current is perfectly conserved. It's exactly the same everywhere in a series circuit. But wait, if the current isn't used up, what actually makes the bulb light up? Well, that brings us to potential difference, or voltage. This is defined as the energy transferred per coulomb of charge. Think of those flowing electrons as marathon runners. They pass by the battery and grab energy, kind of like runners grabbing sports drinks at a water station. When they reach the light bulb, they transfer that energy to the bulb so it can shine. But the runners themselves, the electrons, just keep on going back to the battery. They give up their energy, not themselves. Moving right along to myth number 2, the hot air balloon trap. Let's talk states of matter. We have literally all heard this phrase. In fact, it's so common that even teachers sometimes accidentally say it when we're younger. Heat always rises. And it sounds like common sense. It's why the top floor of a house during summer is always ridiculously warm, right? But listen to me carefully. If you write heat rises in your GCSE physics exam, you are absolutely going to lose the marks. Here is the comparison. The everyday belief is that heat itself is a physical thing that floats upwards. But the physics reality? Particles rise due to a decrease in density. Heat is just a process of transferring energy. Energy isn't some magical floating substance. It is the physical, microscopic particles, the actual atoms and molecules making up that gas or liquid that are doing the moving. And this brings us to the exact step-by-step mechanical process of convection that examiners are desperately looking for. First, the substance is heated, which transfers thermal energy to the particles. This gives those particles more kinetic energy, making them move way faster and spread further apart. Because they're spreading out, the overall volume increases while the mass stays exactly the same. And that means the density decreases. Finally, that less dense fluid rises above the denser, cooler fluid. Hit those exact 4 points and boom, full marks. Now, I just mentioned density, so let's quickly clarify what it actually is. Density is simply the distribution of an object's mass over its volume. This is exactly why a massive, incredibly heavy cruise ship floats beautifully on the ocean, while a tiny, super lightweight metal screw sinks straight to the bottom. It's never just about how heavy an object is, it's all about how tightly packed the matter, the atoms, inside that object are over a specific volume. Okay, let's hit myth number 3, the gravity deception. Time for some forces and mechanics. Here is the setup. Everyday logic tells us heavier objects fall faster to the ground. If you drop a bowling ball and a feather from a window at the exact same time, the bowling ball hits the ground first, right? So obviously, gravity pulls harder on heavy things, making them accelerate faster. Well, prepare to have your mind changed. The physics reality completely shatters this everyday illusion. In reality, absolutely all objects accelerate at exactly 9.8 meters per second squared in a vacuum. Gravity literally treats all mass equally. The only reason a feather falls slower in your living room is simply because of air resistance pushing back up against it. If you sucked all the air out of the room to create a perfect vacuum, which I definitely don't recommend doing at home, the feather and the bowling ball would hit the ground at the exact same millisecond. No way, right? But it's true. All right, section 4, the science of studying science and adapting to your new exams. So, the absolutely crucial takeaway so far is that you can't just trust your eyes. You have to trust the physics. And now that we've busted what to study, let's seamlessly transition into exactly how to study it effectively, because the rules of the game are changing. Look at this massive regulatory shift. For the 2025, 2026, and 2027 exams, you'll actually be provided with formula sheets for GCSE physics. What does this mean for you? It means the game is completely different now. The value is no longer in mindlessly memorizing a formula. It's entirely about your ability to select it, rearrange it, and apply it to a problem. To adapt to this new application-based exam style, we need to look at how we actually learn. And that brings us to this one crucial number, 6. Keep this number front and center in your head when you sit down to revise. The science behind that number 6 is genuinely fascinating. According to researchers at Columbia University, empirical data shows a sharp decline in student engagement after just 6 minutes of watching an explainer or a lecture. The cognitive theory of multimedia learning actually tells us that our brains have a super limited capacity for processing new information. Those long 2-hour study binges where you just read textbooks, they literally just lead to cognitive overload. You're barely retaining anything. So, here is your actionable studied game plan, the golden rules of physics revision. Number 1. Keep your revision learning chunks under 6 minutes. Short, single concept bursts are the absolute sweet spot. Number 2, use active interpolated testing. That's a fancy way of saying you should pause to answer a question immediately after learning a concept to lock it into your brain. And number 3, practice applying your formulas to word problems rather than just staring at the equation sheet hoping it sinks in. We've covered a ton of ground today, from remembering that atoms are made of a nucleus with those free-flowing electrons waiting inside your wires, all the way to the truth about gravity in a vacuum. I want to leave you with a final thought. Next time you see a floating ship, a hot radiator, or plug in a battery charger, are you going to see the everyday illusion, or will you see the physics reality? Equip yourself with the right frameworks, follow the science of studying, and you are absolutely going to crush those exams. Thanks for joining me on this explainer, and happy studying.